Alrighty folks, another bit of an update on the old AC controller project. I've been exchanging emails with Johannes during the week, and he has coded up a very nice web-based interface for the inverter. Now I was having some problems with that, trying to make it work, and of all the things that it could possibly turn out to be, it was my silly $2 USB extension cable. Didn't quite like me standing on it and running a push bike across it, and kind of having it mixed up with the battery leads and all kinds of stuff. So anyway, got to work, and I've managed to scare myself again when I put the frequency up to 300 Hertz and got this thing up to 9,000 RPM. Let's just say I can understand why Harry was a bit annoyed with Cole Trickle when he was doing that to a car engine. I just saw it with a motor. I wouldn't want to see it on a crankshaft. So anyway, back to the here and now. We've this running on the laptop here. The laptop runs Ubuntu Linux 12.04. Had to make a decision to do that some time ago, because when I got this laptop from work, and it was running Windows 7 on it, and I couldn't get any USB serial ports or parallel ports, or indeed any of my electronics project stuff to operate from it, and it just turned out to be a nightmare of drivers and digital signatures and God only knows what else. So I just decided to get shut of it. So anyhow, we're running here now. So up the top we have a little line that just basically gives a little bit of diagnostic info. So for example, the last command that I sent was to set the maximum frequency to 200 Hertz, which is a more sane 2000 RPM for our Siemens motor. So we can see here, set Fmax 200 and response set OK. So we've got some buttons then that we push here. For example, save parameters to flash, start inverter, stop inverter, all of this kind of thing here. Then if we scroll down a little bit, we have the parameters. So what you can actually do now, instead of having to go into the serial terminal, you can just type a value into any of these fields. So for example here, if I go to Fmax, which we just set to 200 Hertz, if I was going to do a cold trickle on it, type in 300 Hertz, press enter. And it'll basically then up the top says Fmax 300 Hertz, response OK. So I'm going to not do that because I really don't want to see 9 grand again. That was bad. So back to 200 Hertz, and that's good. So we can change all of our parameters here. For example, where are we here? Switching frequency 8.8 kilohertz. Number of impressions per rev, or sorry, impulses is the teeth on our encoder. So we've that set to 64 impulses per revolution. So pot min, pot max, those are the values of our throttle pedal. Anything outside of that will cause the inverter to fault out. And down here we have values here. UDC is all to do with our DC bus voltage. Overcurrent limit, I have it set to a fairly sane 150 amps just for testing. And got some current sensor offsets and current sensor gain and stuff like that that I haven't quite tuned in these guys. We have set up, we have added support now for the, or I should say Johannes has added support for the KTY 84 temperature sensor that's in the Siemens motor. So values at the minute, if we just, these are the current values when the website updated. Software version, operation mode, DC link voltage, that's reading a little bit low. It's actually up around 58 to 60 volts at the minute. I just have to set one of those tuning parameters there to just basically dial that in. Speed is at 0 RPM because we're not running the motor. Temperature on the motor is 18 degrees and on the heatsink 16 degrees centigrade. Some of our digital inputs are displayed there, and now there's a facility here to plot graphs, which just doesn't seem to be working for me. My guess is, again, it's just something to do with this browser. It could be the PHP version or something like that that's actually going on there, so we can do that. But just to show that we are indeed getting up to 6,000 RPM, we see our speed readout currently at 0. So what I'm going to do is I'm going to bring my mouse button just up to the refresh there on the browser. I'm going to grab my throttle, and you'll probably hear this thing wind up. Here we go. It's that scary time again. I'm going to hit the refresh. Ooh. Probably just cut it at the wrong time there, I think. No. Regenning back to 0. And as we can see there, just on the exact second that I hit refresh, our starter frequency was at 202 Hertz, and we were at 6,009 RPM. So a few other things there. These were our currents. Went through our current sensors, our DC current, and a few other parameters there. But I just thought I'd do a quick update on this web interface. Finally got it to run, and it's running quite well. So I'm just going to hit the save parameters there on that. Now that I have that back to 200 Hertz, I don't want to accidentally go to 9,000 RPM again. So okay, that's our parameters saved, and my AGMs over there are sizzling away merrily. I just don't think they're that happy with particularly when I dumped the throttle pedal when I was at 9,000 and the regen kicked in. It pumped about 100 amps back into the DC bus. There's a lot of energy in that stator, or rotor I should say, when it's spun up that fast. So yeah, there we are. As I said, I just got to work on getting this plot functioning here, but this would be ideal, for example, to run in a car. I'm sure it'd work on other operating systems as well. And yeah, so that's the web interface operational. I mean, over here we're still pretty much the same as you've seen in the past. Let me just set up there for a second, just for old time's sake. Oh, and by the way, that issue that I was having with the contactor banging away was caused by the fact that I had the start input. This is just this little wire here. I had that connected to 12 volts permanently. Turns out that the software expects that just to go high for a short period of time, as it's designed to run from the start position on an ignition switch. So you just give it a pulse and that starts the inverter, and if we get a overcurrent or any other potential shutdown, that basically drops out the contactor. But when I had that wired up, it was just bringing it back on continuously, so it was causing us a bit of a problem, which we've now solved. So we're well on the way with this, and I'll just give it another quick run just to round out the video. Oh boy. So there we are. And you can hear the way the motor speed drops very slightly and then spins up again. That's the slip control operating. And when I drop the pedal, you just put a 58 amp regen back into the AGMs, and they're definitely sizzling away merrily with that. Okay folks, as I say, just a quick run through on the web interface. It's looking good, and we'll be back with more updates on this project soon, and thanks for watching.